Hi students, welcome to today's class. Today we are discussing about different types of channel. Mainly there are 5 types of channel, that is lossless channel, deterministic channel, noiseless channel, and binary symmetric channel and binary ratio channel. Okay, first we are going to see first channel, that is lossless channel. A lossless channel is a channel distributed by channel matrix with only one non-zero element in each column. That means in each column it occupy only one non-zero element. Okay, so this is the lossless channel. This is the channel matrix P. These are the input, that is row represent the input x0, x1, x2, and column represent the output y0, y1, y2, y3, y4. So each row should have a non-zero value. Okay, then the sum of values in a single row should be 1. So 3 by 4 plus 1 by 4 should be 1 in a channel matrix, and 1 by 3 plus 2 by 3 become 1, and this have the only one value, that is equal to 1. So the addition of numbers in a row should be 1, and each column has only one non-zero value, that is called a lossless channel. Here the number of rows is equal to number of input, that is equal to 3, and here number of columns is equal to number of output is equal to 5. Now we want to construct the channel representation. So channel representation, we have input x0, x1 and x2. We have output y0, y1, y2, y3, y4. Okay, now we are looking each input. X0 have a probability 3 by 4 to y0. So x0 to y0 we have a probability, x0 to y0 we have a probability with 3 by 4. Then we have x0 to y1 we have a probability of 1 by 4. Okay, this is the way of writing drawing channel representation. Then we want to look x1. x1 has probability 1 by 3 when we are transmitting y2. Okay, so probability of y2 when x1 is transmitted. So probability of y2 when x1 is transmitted, that is 1 by 3. Then probability of y3 when x1 is transmitted. Probability of y3 when x1 is transmitted is 2 by 3. And the last one, x2, probability of y4 when x2 is transmitted is 1. So this is the channel representation of this matrix. Okay, so that's about lossless channel. The second channel is deterministic channel. Deterministic channel means only one non-zero element in each row. Each row should have only one non-zero element. That is, here is a one non-zero element, here, P1, P2, P3. But we know that the number of probabilities in each row is the addition of number of probability in each row will be equal to 1. So P1 equal to P2 equal to P3. So here P1 equal to P2 equal to P3 in the case of deterministic channel. So we can write channel representation as x0, x1, x2, and we have output y0, y1, y2. The probability of x0, the probability of y0 when x0 is transmitted is P1, and we have probability of x1 when y0 is transmitted. Probability of y0 when x1 is transmitted is equal to P2. Then we have probability of y1 when x2 is transmitted is P3. Probability of y1 when x2 is transmitted is P3. Okay, so this is the channel representation of deterministic channel. Now we can represent the noiseless channel. In noiseless channel, it is both deterministic and lossless. Then the channel matrix P is equal to x0, x0, x1, x2 is the number of input, and y0, y1, y2 is the number of output. Then we have the channel matrix P is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. That is, it is both deterministic and lossless. That is, the rows contains one non-zero element, and also the column contains one non-zero element. Here then the channel representation become, we have input x0, x1 and x2, and we have y0, y1 and y2. the probability of y0 when x0 transmitted is 1. And the probability of y1 when x1 is transmitted is 1. And the probability of y2 when x2 is transmitted, x2 to y2 is 1. So this is the channel representation of noiseless channel. Now the fourth channel is binary symmetric channel. Here it contains only two input and two output. Binary symmetric channel. It is binary, therefore it has two input and two output. It is symmetric because what is happening in the probability of input, that is same as in the output. That is, a channel is symmetric when the probability of receiving a 1, then 1 when 0 is sent, and probability of receiving 0 when 1 is sent is same. So the probability of, if the probability of 0 transmitting is 1 minus p, then the probability of 0 receiving is p. Okay, so likewise the probability of receiving p when x1 is transmitted and probability of receiving y1 is 1 minus p. Okay, so x is equal to x0, x1 are the input, y is equal to y0, y1 are the output. Now the channel matrix P is equal to 1 minus P, 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 1 minus P. This is the binary symmetric channel representation. Now we can represent, this is the channel matrix. The channel representation can be written as, we have x0 as input and x1 as input, and we have y0 as input and y1 as out. Y0 as output and y1 as output. So the probability of y0 when x0 is transmitted, probability of y0 when x0 is transmitted is 1 minus p. Likewise, the probability of y0 when x1 is transmitted is p. Probability of y0 when x1 is transmitted, x1 is transmitted. Probability of y0 when x1 is transmitted is p. Likewise, probability of y1 when x0 is transmitted, probability of y1 when x0 is transmitted, okay, that is p, and probability of y1 when x1 is transmitted, that is 1 minus p. So this is the channel representation of binary symmetric channel. In binary symmetric channel, a channel is symmetric because the probability of receiving a 1 when 0 is transmitted and the probability of receiving a 0 when 1 is transmitted is same. So the name is called a binary symmetric channel. Then next channel is binary erasure channel, that is BEC. In binary erasure channel, since it is binary, it has input as 0 and 1. So the input will be 0 and 1, but it is not symmetric. Therefore, the output may or may not be 0 and 1. So if you are transmitting a 0 input, the probability of receiving 0 as the output, 1 as output, and a noise as output will be there in the case of binary erasure channel. So there is a probability of erasing the output. So if you are transmitting 0 or 1, the output may be 0, 1 or any other noise. Okay. So the probability, the channel matrix of binary erasure channel P is equal to 1 minus P, P 0, 0 P 1 minus P. X0 and X1 are binary input. Output may be three types, that is Y0, Y1, Y2. It may be, if we are transmitting 0, we may get 0 or 1 or any other noise, that is mix of that. That means 0 and 1 is erased version of 0 and 1. So we get three output. If you are transmitting X0, the probability of getting y0 is 1 minus p, y1 is p, then y2 is 0. And if you are transmitting x1, the probability of getting y0 is 0, then y1 is p and y2 is 1 minus p. So the channel diagram can be written as, there are two input, that is x0 and x1. We have three output, that is y0, y1 and y2. When x0 is transmitted, the probability of getting y0 is 1 minus p. When x0 is transmitted, the probability of getting y1 is p. Okay. At the same time, this is the noisy version. At the same time, if x0 is transmitted, the probability of getting y2 is 0. If x1 is transmitted, the probability of getting y0 is 0. And if x1 is transmitting, the probability of getting y1 is p. And if x1 is transmitted, the probability of getting y2 is 1 minus P. So this is the channel diagram of binary erasure channel. If x0 is 1, so the probability of getting a 1 or a something, a noisy version of 1 is the probability of x0. And if x1 is 0, the probability of getting 0 and probability of getting a noise is something, a erased version of this is the probability y1. So here, since it is binary, it has two input and it may be three output, because the probability of transmitting 0 is maybe the probability of when we transmit 0, it may be in the output of the channel we may get 0 as the output, 1 as the output, or the a noise as the output. So this is the case of binary erasure channel. So these are the 5 types of channels, that is noiseless channel, deterministic channel, lossless channel, binary symmetric channel, and binary erasure channel. So that's all about today's class. Thank you.